Welcome to the Explainer. Today we're jumping right into the hierarchy of electrical distribution to finally clear up the confusion between three absolutely critical pieces of equipment: panelboards, switchboards, and switchgear. You know, if you've ever stared at a single-line diagram and second-guessed exactly what kind of equipment you're actually dealing with, well, you're in the right place. We're going to break the whole thing down, from the absolute basics all the way up to complex engineering specs.
I've structured this explainer into 6 clear sections. We'll be covering why the confusion, defining the power hierarchy, panelboards, frontline distribution, switchboards, the middle ground, switchgear, top-tier performance, and finally, making the right choice. Section 1. Why the confusion? Let's go ahead and address the elephant in the electrical room.
So why is it that these terms get mixed up constantly? Not just by beginners, but by seasoned pros right out there on the job site. Well, the reality is, at the drawing level, they all basically look like metal-enclosed assemblies with buses, protective devices, and wiring terminations. To the untrained eye, or honestly even looking at vendor catalogs where terms like distribution board get thrown around super loosely, they just kind of blend together into these gray metal boxes sitting on the floor or attached to a wall. But, as our source material from the National Electrical Code points out, we absolutely cannot rely on that casual vendor terminology. The NEC makes very strict distinctions here. A bad label isn't just an innocent typo, it can literally ruin your service entrance specs. Worse, it creates incredibly dangerous assumptions about access. Just imagine an electrician walking up expecting a front access-only panel board, but instead they're face-to-face with a switchboard that has exposed energized rear buses requiring totally different clearance rules. Yeah, that's a massive safety hazard.
Moving right along to Section 2, defining the power hierarchy.
Let's start at the bottom and work our way up. Downstream, we have the panelboard. This is your compact front access-only equipment designed specifically for branch distribution. It lives inside a cabinet, mounts securely right against a wall or a partition, and structurally speaking, it is strictly accessible from the front. If you need to wire it, inspect it, or swap out a breaker, you are doing every bit of that from the front face.
Taking a step upstream, we hit the switchboard. Now, notice the key differences here. A switchboard breaks completely out of that wall cabinet. It's a large, freestanding structural frame resting directly on the floor. And here's the kicker. While it can be front accessible, it might also be designed for rear access. That is a really big deal, because rear access demands dedicated floor space and strict clearance zones behind the equipment, which totally shifts how you have to engineer the layout of your electrical room.
Then, sitting pretty at the very top of our power hierarchy is switchgear. Switchgear is defined by its highly compartmentalized construction and its peak fault duty performance. Basically, it's engineered to safely handle massive, explosive surges of destructive energy without completely failing. We're talking power circuit breakers, either stationary or draw-out, safely housed in their own individual, heavy-duty metal compartments.
What's really fascinating here is how clearly the governing U.S. standards separate these 3 classes. Panelboards are strictly governed by UL 67. You step up to switchboards, and suddenly you're looking at UL 891. Jump up to switchgear, you are entirely in the realm of UL 1558 and some incredibly rigorous IEEE standards. You can even trace this progression just by looking at how the devices are mounted, starting with fixed plug-in breakers in panelboards, moving to mostly fixed layouts in switchboards, and culminating in advanced draw-out power breakers in switchgear.
All right, Section 3, Panelboards, Frontline Distribution.
Now that we have the 30,000-foot view, let's zoom in on that frontline equipment, 1,200 amps. To put that number into perspective, 1,200 amps is enough current to power a huge chunk of a standard commercial office floor. We're talking running hundreds of computers, all the overhead lights, and localized cooling units all at the exact same time. It's a lot of juice. But in standard commercial practice, 1,200 amps is typically the maximum incoming main capacity you're going to see for a panelboard before you're forced to upgrade to a heavier class of equipment.
Because of that lower capacity, their limited depth, and the fact that they're front access only, a panelboard's real job is handling final end loads. They are completely optimized for downstream branch circuit distribution. Think lighting, receptacles, HVAC branches, subfeeders, stuff like that. They are absolutely the perfect choice for tight electrical rooms or tenant corridors where your available depth is at a premium and you just can't afford the footprint of freestanding gear.
Oh, and before we move up the chain, we have to bust a major myth, the whole load center thing. You're probably wondering, wait, where does a load center fit into all this? Well, according to the NEC and UL, there is zero difference, literally none,
at the code level between a panel board and a load center. Load center is really just a residential marketing term used for lower-cost consumer-grade panel boards. When you're dealing with commercial specs, always use the proper code terminology, which is panelboard.
Section 4. Switchboards, the middle ground.
Let's step it up and look at the real workhorse of commercial buildings. Just look at that massive leap in capacity. We went from a 1200 amp ceiling straight up to a staggering 6,000 amps. That's 5 times the power. At this level, a single switchboard can act as the primary heartbeat for an entire large-scale facility. It takes the massive power feed right from the utility transformer and safely splits it up for the entire building.
Switchboards really hit the sweet spot. They give you an excellent balance of high capacity and practical economy. Plus, since they're freestanding, they can incorporate dedicated CT metering compartments. If you don't know, that's just a section built exactly to local utility specs where they measure your massive power consumption. This flexibility makes switchboards the absolute go-to standard choice for main service entrances in places like office buildings, hotels, retail centers, and light industrial facilities. Section 5. Switchgear, top-tier performance. Now we're entering the heavyweight division of the electrical world, where system reliability is everything. The numbers here are just wild. Switchgear is engineered to handle main bus currents that commonly range all the way up to 10,000 amps. That is heavy industrial-scale power, my friends. We're talking the kind of energy you need to run sprawling manufacturing plants, massive server farms, or multi-building hospital campuses. Dealing with 10,000 amps takes serious engineering respect and a fundamentally different structural approach.
But honestly, the sheer power isn't even the most crucial point here. It's the architecture. Switchgear is defined by strict compartmentalization. It features draw-out functionality, which means a breaker can mechanically move through connected, tasked, disconnected, and removed positions. This is all about ultimate safety and zero downtime. It means you can physically isolate, remove, and swap out a single massive breaker, while the rest of the hospital or data center stays totally online. Throw in tested arc-resistant options, and it makes total sense why switchgear is absolutely mandatory for mission-critical facilities.
Section 6. Making the right choice.
All right, let's take all these standards, mounting styles, and access requirements and turn them into a practical, real-world framework you can actually use. It all starts with fault current. Your equipment's short-circuit rating has to match or exceed the available fault current at its installed location, which, by the way, is always highest closest to the utility source. So here's your quick screening guide. Dealing with up to 10 kiloamps, a panel board is fine. Pushing 35 to 100 kiloamps, you're defaulting to a switchboard. Sourcing over 100 kiloamps for low-voltage main distribution, switchgear is usually preferred, or even outright required for safety. So when you're engineering a project or reviewing a spec, you really need to follow this exact sequence. 1. What's the available fault current? 2. What is the required continuous current rating? 3. Assess your maintenance philosophy. Do you actually need the draw-out isolation of switchgear so you never have downtime, or will a fixed switchboard do the job? And 4. Factor in the room geometry. Do you only have shallow wall space, or do you actually have the floor space for rear access gear? Notice how we have to figure all of this out to ensure safety and functionality long before we ever start talking about the budget.
Which brings us to our final takeaway. Choosing between these three isn't just an argument over semantics, it's quite literally about life safety and system integrity. So the next time you design a space or look at a single-line diagram, I want you to ask yourself these 5 critical questions. Do you truly understand the hierarchy, the physical constraints, and the immense fault-duty power flowing through your building's infrastructure? Or are you just staring at another gray metal box?